Welcome to the 181 General Chemistry KSP of Calcium Iodate Lab. Here we're measuring out 50 milliliters of 0.2 molar potassium iodate. Pouring that into a beaker. And then we're going to measure out 20 milliliters of 1 molar calcium nitrate. We've mixed those two together. Now we're going to stir. And the calcium iodate precipitate will form. Going to stir this for a while longer so that it's completely crystallized, and set up a funnel for filtration so that we can collect our precipitate. Going to wet our filter paper and stick it to the edges of the funnel. And we're going to pour our entire solution through. When doing a filtration, it's easy to let the precipitate settle, filter the clear liquid, and then scoop the rest of the precipitate and wash it through. If the precipitate is suspended, it can clog the funnel, making filtration take that much longer. We're going to rinse it a couple times with some squirts of deionized water. Then we're going to divide our precipitate into roughly 3 equal portions, which will be used for our 3 different titration trials. Gonna label some beakers A, B, and C. We're gonna add 40 milliliters of water to beaker A, 60 to beaker B, and 80 to beaker C. And then we're going to spend 40 minutes regularly stirring each of the solutions. We're going to rinse our burette a couple times with deionized water. And here is our sodium thiosulfate that we're going to be titrating with. You need to write that concentration down. We're going to now rinse our burette with our sodium thiosulfate solution. I did one rinse straight through, and I'm doing another rinse where you're actually turning it sideways and rinsing all of the insides of it. Gonna let that go through and then fill the burette all the way up. Gonna make sure that there's no air bubbles in the tip. And there's our initial volume that we're gonna use for solution A. We're going to rinse this pipette with deionized water preemptively, and we're going to measure out 3 different measurements of 1 gram of potassium iodide solid for the purpose of using it as an indicator with starch solution in our later titrations. Here we're going to filter out solutions A, B, and C. This time we are not going to wet the filter paper because then that would dilute our solution. So we're doing dry filtrations. We want just the saturated solution, so we don't want to use any of the solid in our titrations. So we're going to get just enough to about fill each test tube 2/3 of the way full. Our trials will only involve 10 milliliters, so we have extra in case we make a mistake. And we're just going to allow those to filter with gravity. Now we're going to take our 10 milliliter pipette, and before we do a titration, we need to rinse it twice with the solution that we're going to use. So here's my 2 rinses. And we're almost ready to begin solution A's titration. So I'm going to fill my volumetric pipette above the line and then down exactly to the line. And then I'm going to empty that out into my Erlenmeyer flask. We're going to add about 20 milliliters of water to this. This is not exact, so I just poured some from my squirt bottle. I'm going to add one of our 1 gram samples of potassium iodide and dissolve it. And then we're going to add our 20 drops of 2 molar hydrochloric acid. The solution then turns a dark red-brown. Add a stir bar. Gonna lower the burette. Gonna take our initial reading, but that's the same that we showed before. And we're ready to begin titration. We're gonna do the first titration at pretty normal speed so you can see how gradual the color change is. And I have my hand ready just in case it starts rapidly changing color so that I can turn the stopcock off. I notice it's getting a little bit lighter, so I'm slowing the rate of drops falling. The red-orange color is turning yellow-orange and starting to turn more yellow. I decide that's about yellow enough. And it's time to add our 4 drops of 1% starch indicator. Starch and the iodine react, making a dark purple complex that looks almost black. We'll see the purple color as we start to titrate a little bit more. We're doing this so that we can get a more obvious endpoint rather than the gradual color change. And our solution is completely clear. So we have reached the endpoint of our titration, and here is our final volume of our sodium thiosulfate solution. Remember to record that to 2 digits past the decimal place, because each marking on our burette is 0.1 milliliters, and we need to measure to one uncertain digit, so we need to go one digit past. Here I've rinsed my pipette again with the new solution B, and measured out 10 milliliters, added water, added potassium iodide, and added the acid. Here's our initial volume, which you may notice is pretty much the same as the end volume from before. We didn't change anything in our burette. This titration will be sped up a little bit more. Time to add our starch. This time I'm going to try to be a little bit more careful. And I'm going to use a technique to add about a half drop by rapidly twisting the stopcock 180 degrees. It's still a little bit purple, so I give it one more, and we're at our endpoint. Here's the final volume. Now for solution C. Get our rinses. Measure our 10 milliliters to the line. Dispense. Add some water. Add our potassium iodide. And our 2 molar hydrochloric acid. We had to refill the burette somewhat. So here's our new initial volume. Solution got yellow, added starch. And as we're about to end, remember you can go and see online TAs for help making sense of your DAS. You have a lot of people around to help you. Don't be afraid to email your instructor or get help from one of the online TAs. Here's our final volume. Hope you enjoyed!